Now that we've sort of laid down the ground rules for functions, let's talk about functions in relation to algebra. Functions are pretty much exactly what we've been doing this whole time. We've been putting in x values and trying to solve for y values. That's basically what a function is. A function is saying we have an input value and we look for an output value of some kind. And the only thing that's really any different about what we're doing is all we're saying is that for every x there can only be one y. And everything is the same pretty much, and the only thing I really want to introduce here is the function notation. So in the past, what we've done for algebra, let's say we've had an equation y is equal to 2x plus 1. In functions, it's exactly the same thing. We're solving for an x to get a y. This is basically a function. This is the function, and this is where the input would go, and this is the output. This is in, out. And the only real difference is we use function notation. So if I was to write this in function notation, it would be, that's a really crappy f. It would be f of x is equal to 2x plus 1. And f of x means, this means the function value at x. So let's say I put in a 0 for this equation over here. I get y is equal to 0, or 2 times 0 plus 1, which gives me y is equal to 1. So this is exactly the same thing. I'm doing f of 0 is equal to 2. Didn't mean to put that there. 2 times 0 plus 1. So this is kind of, it makes it a little bit more clear. It says what we're putting in for our function value, which is 0. And then we still get the same answer. 2 times 0 is 1. So f of 0 is equal to 1. And this might be a little confusing why we would go from y to f of x. And it's not really going to be apparently obvious again until much later in calculus and in differential equations and so on and so forth. Because it would seem to make more sense to just put in y, because it's, I mean, this seems like more clunky notation. And to be honest, it doesn't really matter for now. Actually, it doesn't really matter at all. If you feel like using y for the rest of your life, that's fine. But later on, it's going to become more convenient to use function notation. I remember when I first learned about function notation, I didn't use it until I was in calculus, pretty much, because, and even then, I still preferred to use y, but I ended up using the function notation just because it becomes more convenient to use. But for right now, all we really need to know is that f of x is equal to y, and that it's the same thing pretty much. And I mean, for now, you can use whichever you like, but obviously in this section we're going to be learning about function notation. So let's use a little bit of function notation. Let's suppose let's do the same thing. Let's do f of x is equal to 2x plus 1. And I want to know what f of 3 is, and f of, let's do something a little bit different. Let's do a plus 2. So let's do f of 3 first. If I want to find out what f of 3 is, I'm going to say f of 3 is equal to 2 times 3 plus 1. That gives me 6, so f of 3 is equal to 7. And if I want to do this one, I do f of a plus 2 is equal to 2 times a plus 2 plus 1. So that's going to give me f of a plus 2 is equal to a plus 4 plus 1. So f of a plus 2 is equal to 2a plus 5. And these are our two answers. And like I said earlier, this notation might seem a little bit cumbersome, but I'm only writing f of a plus 2 repeatedly. It's just so everyone can see it. I mean, when I'm solving my problems, I kind of just do the f of a plus 2, and then I just don't really write it anymore. I just kind of go down and says equals, 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 equals. So, like I said, it's kind of hard to see at this point in time to see why someone would want to use this kind of notation. And it's, like I said, it's just not at all obvious until later on when we're doing different things. It's just a more convenient notation for writing what kind of derivative you're using. And also in calculus, we're going to be taking a lot of there's all kinds of different tests and tools that we're going to use. And if you just write y, and you're going to become easily lost. The nice convenient thing about this is, or at least one of the benefits I think of it is when you're testing for points, it's very easy to see what point you tested for. F of 3, so I'm substituting x in for 3. So that's basically what this is. It's basically f of x is basically saying what x value you're going to substitute in. So what x value you're going to substitute, you're going to put into the equation. Because everyone knows, I mean, it's kind of understood that the other side is the output, and that's y. So I think that's the only real benefit that you can see for now. Like I said, it's just something we learn in college algebra real early, and we don't really see the logic of it until much, much later. So if you feel like using y, and if you're more comfortable using it, like I can definitely understand. I didn't really see much point of using f of x notation until much, much later. So if you feel like continuing to use y, use it, and later on, that's what ends up happening is you just end up kind of falling into using the notation. I remember I was using y for almost all the time, and then only using f of x when I thought it was more convenient, and then after a while, I just ended up using it continuously. So that's all I have to really say about it. This is just kind of an introduction to where we're going to go with functions as far as algebra is concerned. And next we'll talk about domain and range and what kind of algebra equations are functions and what kind are not functions.